All right, today we're going to be learning 2.2 quadratic transformations part 2. So we're going to be taking a lot of what we learned in the last one and finally talking about what that a value does. Your only learning goal is to stretch, compress, and reflect quadratic functions in vertex form. So last lesson was all about, shifting it up, down, to left, to the right. And this one is going to be more about changing the actual shape in the direction that it is headed. So we are going to split this up a little bit again, okay? We have some definitions here, and we're going to go to Desmos after this to quickly kind of observe these three words. So the first one is stretch, a transformation that occurs when the absolute value of a is greater than 1 and it results in the parabola looking narrow. Now, I want to address this absolute value here, okay? What we're saying is that, a is -1 and a is +1 have the same exact result on the parabola, but in a different direction. So if you have a as a 5, it might get really narrow upwards, okay? But if a was -5, it might get really narrow downwards, okay? So our graph will be getting more narrow from the parent function, okay? So I have to put that absolute value there to kind of get rid of the negative to have that single inequality, okay? So if you have an a value greater than 1, it'll stretch and it'll get more narrow. Okay, compression and shrink, a transformation that occurs when the a value is between 0 and 1. So 0 is less than the absolute value of a, which is less than 1, and results in the parabola looking wider. Now again, we have that absolute value because -0.5 or -1/2 and +0.5 and 1/2 have the same exact effect on the parabola, but in a different direction again. And we are looking for something that is going to look more wide, okay? Now you've already really been hearing about reflection, okay, already. So flipping a graph over a line or an axis. When we see a negative value, -1, -2, -0.5, etc., that will cause our parabola to go down instead of up. So if I had a parent function of x squared and it was going up, and then I had a function of -x squared, that would mean a is -1, it would look exactly the same, but it would be going down now. So we call that a reflection. Now, all of this is dictated by just this a value, okay? And it results in a lot of things. It results in a stretch, it results in a compression or shrink. You're going to hear me use compression more than shrink. And then it also results in a reflection. So you really, before graphing, want to start looking at that a value and, kind of see what it's telling you. Okay, so here we're back in Desmos, just like we were in the last lesson. I really want to talk about our a value this time. So here we have our parent function, the most simple quadratic we can have, because h is 0, k is 0, and a is 1, which is shown in those sliders. And, I told you if the absolute value was greater than 1, we should see it stretch. So watch it. See it's getting more narrow as I increase the a value. Okay. Now let's go back to 1. Okay, so that was a stretch. If your value is greater than 1, not equal to 1, greater than 1, you have a stretch. Okay. Now let's look at that between 0 and 1. Notice that. Look at that. 0.1, it's wider. Right? As I go down from 0.9 to 0.1, we see it get wider. Okay. Now again, that's only at 0.1. You might be thinking, well, as soon as I go to 0 or to -0.1, it flips. Like, couldn't it have gotten more wider than that? It absolutely could have. So it's hard to keep it on 0.1. It could have been 0.0001 or something like that, and that would have really made it look super wide, okay? We call this compression, right? In this distance between 0 and 1. Notice how, let's see if I can get this right onto 0. Okay, notice how when we get to 0, we have just a line, okay? And that's because, remember, anything times 0 gives you 0 again. So if you have x squared and you get a number and then you multiply it by a value of 0, you no longer have a quadratic. So that's why it can't be at 0. Now watch what happens when we go to the negatives. Now negative 0.1 to negative 0.9, it's all compression still. Okay, it's all compression. It's able to get wider, but it's just below the x-axis. So let me make this, there we go. Okay, so let me go down from 0.1 to 0.9. You can see it's getting closer together, but we like to think of it more as we go down in the number, we get wider. We compress more, okay? And then let's keep looking at those negatives. So let's go down to, negative 10, and we could see it's stretching now, okay? So, I hope this visual helps you rapidly see how our A value changes this, okay? Think of it this way. If you have a negative A, it's reflected. It's going to go down now. If you have a positive A, it stays up. If your A is greater than 1 or less than negative 1 technically, right, you have compression. And, let's simplify that, right? If it's 1 or above, right, if you take the absolute value of it, it's 1 or above, you have stretch, okay? If it's between 0 and 1, you have compression. Now we're back in our notes. We're going to do everything that we've been doing. We're just going to go a little bit faster now, okay? And we're still going to bring those vertical translations back in. So everything's normal. We start off with H. H is the opposite. It's negative 3. There's no K. So we have a vertex of negative 3, 0. The next thing I want you to do is identify stretch or compress, okay? So the value is greater than 1, so we have stretch. So it should be more narrow. And then we have an A value of 2. It's really good to just identify that information off the bat. Now I'm going to put my parent function in, and we're still going to transform this, but I'm going to start by taking in the A value. I'm going to start by transforming with the A value and then doing the shifting, okay? So all these points would have gotten multiplied by 2. So I'm going to just go off the bat and multiply their Y values by 2. So this would have been 4, this would have been 1, that would have been 0. So 0 times, let me do this in red, it's going to be a little bit more distinct. 0 times the A of 2 just gives you 0. So it's still on the same point, okay? 1 times 2 gives you 2, so it would be up a little bit here and here. And then 4 times 2 gives you 8. So 5, 6, 7, 8. Let's see, 6, 7, 8, that's right here. And so those would have jumped up way higher, okay? So, let me label these colors. So purple is the parent function, and then the red is transformed by the A value. Okay, so all I did was take all the parent function points that we had, and I multiplied them by A. Now the next thing, I'm going to do this in green, is I'm going to do our vertical translation by our H value here. Okay, actually, sorry, that's a horizontal translation. Excuse me. Okay, so we have negative 3, so we need to go to the left 3 spaces on all those points. So that would be here, that would be here, that would be here. Let's see, 1, 2, 3. Am I doing something wrong? 1, 2, 3. 1, 2, 3. Why did those end up on top of each other? Oh, okay. Silly mistake. I went to my purple points. I should only be going to my red points in doing this, okay? So 1, 2, 3, 1, 2, 3, and then 1, 2, 3. So my apology for the confusion there. I started going to the purple points. I needed to go to the red points and transform them. And so this would be my final place here, okay? And I mean, we could even verify this if we wanted to, right? We see that at x is negative 3, we get to 0. So if I plug in x of negative 3 plus 3 is 0. 0 squared is 0. 2 times 0 is 0. So I do have that point of negative 3, 0, right? So that shift should have been to the left there, just like we did, okay? So it's a little bit more going on now, all right? We're just adding in that A. I highly recommend doing the A before the other ones, but we could have done it either way. We would have ended up in the same place, okay? Now we do need to do our domain. This quadratic is going forever to the left and right. You're going to see that theme a lot. All real numbers. And now our range, it didn't shift up and down. It only shifted to the left and it stretched. So our range would still be what it would be for the parent function. Y is greater than or equal to 0. Okay, let's do another one. All right, this time we got to do one with a compression. So I'm going to quickly move through this. All right, so H is 1. It's the opposite. K is what you see is what you get, -4. So we have a vertex of 1, -4. Then we look stretch or compress. It's between 0 and 1, so we have compression, so this should be getting wider, okay? And then our A value is 1/2. So in the previous one, you multiplied them by 2. You're going to multiply them by 1/2 this time. And if you think about it, if you multiply anything by 1/2, it just takes 1/2 of it, right? So if you multiply 4 by 1/2, it's 2. Okay, so let's start with our parent function, which I will do in purple. And I'm going to start by, so that's parent function, okay? And then in red, I'm going to do the compression, okay? So I'm going to take half of all these points. So again, the first point at 0, right? Because we're only looking at the y values. 0 times 1/2 is just 0. So I'm back to that same place. Now, these first points have a y value of 1. So 1 times 1/2 is 1/2 or 0.5. So now I'm half the distance there. Now these next points up here have a value of 4. 4 times 1/2 is 2. So you see how it's compressed downward. Each of those points are compressed downward. And then in green, I will do the H and the K shifts. I'm just going to call them like that, okay? And I'm going to do them at the same time. So we have a positive H, so we should go 1 to the right, and then we should go down 4 for all the red points. So 1 to the right, down 4. That's where our new vertex is, okay? I went 1 to the right, down 4. Do it for the rest of them. 1 to the right, down 4. 1 to the right, down 4. Notice how if I'm at 0.5, I should end up at 0.5 again. You know, something 0.5 again, right? And then the last points, 1 to the right, down 4. 1 to the right, down, whoa, no, not there. That would be here. Notice between this red one here, right, and this green one, the shape is identical because we just moved its position. But between the purple and the red, its shape definitely changed. Now, because this is compression, when I go to draw this, it should start to look wider. I should be drawing these out wider than I normally would, okay, because we had compression. And then domain and range, all real numbers. And then range, we've dropped down now. Look at our lowest y value is here at -4. So y is greater than or equal to -4. Okay, let's jump to the next one. All right, this one is for you guys to do. Identify all of your pieces, transform your quadratic. Okay, so hopefully you tried that. I'm going to jump through quickly and show you guys what the answer should have been. So h would have been -2, k would have been 1. Your vertex would have been -2, 1. Our a value is greater than 1, so it's stretch. So put a 2 there. And then I'm going to go through, I'm going to put my parent function. And I'm going to start with the a value. So if I multiply these points by 2, it should kind of look like the example that we did before. We should be on our original point, and then each of their y values should have doubled. Okay, like that. And then in green, I'm going to do the h and the k. So -2, so we got a left 2 and up 1 for all our points. So from the vertex, we should be here. Left 2, up 1. And I'm doing this from the red. Nope, I'm doing this from the purple points. Left 2, up 1. Left 2, up 1. Left 2, up 1. Left 2, up 1. And because this was a stretch, it should be more narrow this time. Okay, and you should have gotten that. Now your domain, all real numbers. I hope you're seeing a theme there. Nobody should get a question wrong about the domain of a quadratic unless your quadratic has any, limits or cuts, or it's an inequality, something like that, piecewise. But just a standard quadratic, all real numbers. And then your range did shift up. Your lowest y now is at 1, so y is greater than or equal to 1. Notice when you have an a that is positive, it is always going up, okay? Now we need to get into reflections next. Reflections is going to put our graph downward now. So I'm going to run through all the same stuff. So h is 0 because there was no minus or plus in there, right? We just had an x squared. K is -2. So we don't have anything to left or right. We only have up and down. And then we do have compression because our, once we take the absolute value of a, our value is in between 0 and 1. And so then we have -1/2. So we do have a reflection. So I'm going to draw the parent function in purple. So parent function is in purple. And then in red, I am going to do the a value, and I'm going to do the reflection and the compression at the same time. Okay, so 0, which is our y value for the vertex, times -1/2 is just 0. Now here, when I take these values, which are at +1, if I multiply them just by +1/2, I get 0.5. But if I multiply it by -1/2, I get -0.5. I still have the same number, but it's now a negative. So instead of going to +0.5, these should now be down here, okay? Now that is very important to notice there, all right? In addition to it moving down to 0.5, it also got reflected over the axis, the x-axis, okay? Or whatever line this should be at, okay? Or whatever line your vertex is at. All right. Now, you could have done that in stages, all right? So let me just show you that one time again. You could have multiplied it by the positive and said 0.5 first, and then been like, okay, but because it's negative, I can flip these over to the -0.5. And I think doing it that way might help a lot more people because they see exactly where it's supposed to be on the positive side and then just put it to the negative. Okay, but I will leave that up to you guys to choose how you want to do that. So then here we have a +4. So you multiply it by -1/2, you should get -2. So that should be down here now. Okay. So I did the reflect and the compression in red. And then finally we need to take care of our k value, which I'm going to do in green, which is just all these points go down 2 places. Like that. All I did was just shift them down 2. And now remember, this was a compression. So we should try and be wide with our points. They should not be skinny or narrow like a stretch would be. Now our domain, you guessed it, all real numbers. And then our range now is going to be much different. It's no longer greater than or equal to because we're going down now. Our highest value is -2. So y is less than or equal to -2. Okay. So here's one for you guys to try with a reflection. Give it a try, and then I'll go over it. Okay, hopefully you gave it a try. I'm going to run through this pretty quickly. Again, we have an h of 0. We have a k of +2. Our value after our a value after we take the absolute value would be between or greater than 1. So we have a stretch. I'm sorry, our vertex 0, 2. And then this is a -2, so we have, you guessed it, a reflection. So our parent function, hopefully you're getting really good at drawing that parent function. And I'm going to do the a value first. So here we go. This was our parent function. And then in red, we have our a value. Sorry, let me do that differently. We have our stretch. and our reflection. Okay. Now we do it for the vertex where it just stays where it is, right? Because -2 times 0 is just 0. Now these values are at 1 and 4. So let me actually write the math for you this time. All right? 1 times -2 gives you -2. So that value should be down here. And then 4 times -2 should be -8. So that should go down here. Okay. Now remember, you could have thought about where it was on the positive side first and then flipped it. Either way is fine. And then in green, I'm going to do the k value. Okay. So we see that it has a k value of 2. That means it shifts up 2. So all these points are going to go up 2 places. Now it's starting to look kind of weird because it's all over each other. Those having colors for this, you could tell, is super helpful. And then it should be kind of narrow. Whoa, that's an eraser. Because it was a stretch. Okay. So hopefully you got that right. And we have one more concept to go over, right? Describing the transformations, right? Now we've done the h and the k already, but we still need to talk about it because they're here, all right? So this is a -9, yes, but that means that h is a +9. So the first thing we would write is a horizontal shift 9 units right. Notice how I'm not saying, you don't ever really see me put positive and negative stuff there. I use the direction in my description. Then we have a vertical shift 1.5 units up. This would just be like the last lesson, but now we have an a value of 4. And so you need to use those words, stretch or compression, by a factor of the a value. So because it's greater than 1, this is a stretch by a factor of 4. Okay. Now, if that was like a 1/4, you would say compress by a factor of, 1/4. Okay. If that's what it was. So you need to do all 3 of these things. So here's one for you guys to try, and I'll go over it after you try it. Okay, so hopefully you got it. Let me show you what the answers would be. For starters, h would have been 0. So there is no horizontal translation. There's no horizontal shift. So it's good as it is. But there is a k value of -12. So you would say a vertical shift 12 units down. Now, keep in mind, you might see this described different ways. You might hear, vertical. It was vertically translated, 12 units down. I like to try and show it to you multiple ways. I think in the last video I did a little differently, because when you go out there and look at the math and see other people do it, there are sometimes different standards or just a little bit different language that we use. And I want you to see it all, okay? And then we have 1/2 for a, so that's compression, right? So we would say compressed, or you might hear shrunk, compressed by a factor of 1/2, okay? And because there was no horizontal shift, we didn't write that, okay? So this is actually the end of the video. I hope you guys learned something. If there are any errors, please let me know. And good luck.